Hey, 6th graders, our next lesson is 7-4 called Understanding Cross Multiplication. And the goal today is to use the strategy called cross multiplication to solve proportions. Now, proportions are just fractions that you can find from a rate table or from a ratio table. And basically, kind of just like we were talking about at the end of our lesson yesterday, when I was trying to give you kind of a heads up on the homework, basically what we said was if you have a factor puzzle that, I don't know, maybe it looks like this, and you're trying to solve it, instead of just having an empty number right here, you might have something like a variable or an x. And we know there's lots of ways to solve this using factor puzzle style. That would look like this. Hey, how do I get from 2 to 8? I multiply by 4. So I'm going to do the same right here. 3 times 4, and my missing number is 12. Hey, that's one way to do it. We've also talked about that same factor puzzle could be solved like this. And you could say, hey, the factors they have in common are 2. So 2 times 1 gives me 2. Slide that 2 across. 2 times 4 gives me 8. Slide that 4 across. Slide my 1 down. 1 times 3 gives me 3. Slide the 3 across. And then my final box can be solved by solving 3 times 4, which is 12, which is the same answer we had before. Now, there's one more way to solve. Like we talked about at the end of our lesson yesterday, is turning these into fractions. This is written as 2/3 is equivalent to 8 over the fraction x. And those are called a proportion, or this is called a proportion. And we're going to talk about a strategy today that Miss Billman, if you watched her homework video yesterday, you saw her use it throughout her whole video, because she taught her students that a lesson early. It's called cross multiplication. And basically what we're going to be looking at today is why this method works and how does it work. So if we have the proportion 2/3 equals 8/12, I'm going to move that to the top of my whiteboard here so we have room to work. The strategy called cross multiplication works like this. If you cross multiply, that means take your fractions and go in this direction. On this side, you're doing the multiplication problem 2 and 12. So 2, gosh, I wrote that wrong. 2 times 12. And on the other side, if you cross the other way, you have 8 times 3. Now, these will always be equivalent if your fractions were equal. If your fractions did not start out as equivalent, then this strategy will not work. This is a method of solving for an unknown variable in a proportion. But we're going to show why it works right now because we have all 4 of our numbers already filled in. So we can see that 8 times 3 is 24, 2 times 12 is 24, and they are equal. Now, this is always true. If you multiply from top left to bottom right, you get this cross, and top right to bottom left, you get the other side of your cross, you will always have equal products every single time if your fractions started out as equivalent. And the way that would work, if you did not know the answer, would be this. 2/3 equals 8 something. If we use the strategy of cross multiplication, on this side we would have 8 times 3. On the other side, we would have 2 times x. And then we could solve because we know that these have to be equal because that's what the rule is that both products when you cross multiply are equal. The left side is clearly equal to 24. And we can solve for x just by looking at it. 2 times something gives us 24. But if you wanted to use the math rules that we've been talking about, you could do this. You could say 24 equals 2 times x, in other words, 2x. And the opposite of multiplying is dividing. So if we want to isolate x or get it all by itself, this happens to go back to a few lessons ago. The inverse operation would be to divide by 2. And if you divide by 2 on one side, you need to divide by 2 on the opposite side. And that would leave your x all alone, isolated, and you get your answer. 24 divided by 2 equals 12. So x in this case would be 12. So this is how cross multiplication works. And this is what our whole lesson is going to be using today. Sometimes the numbers get larger and more tricky, but that is the basic idea in the lesson. And as long as you can multiply and divide, you are going to have zero issues with this lesson at all. I think cross multiplying is a great strategy. It's probably why Whitney Billman taught her kids that a week or one lesson early, is because it makes so much sense to solve factor puzzles and proportions. So this first half of our page is just showing us basically what I just showed you guys of why this works. If you have 10/15 and it's equal to 18/27, they're showing you could solve it, proving it with a factor puzzle, and they're showing you could also cross multiply. Basically, if I do it bigger so you can see better, 10/15 equals 18/27. What they're showing us in these pictures is that 10/27 would be 10 times 27 on this side, and then on our other side it's equal to 18 and 15, so 18 times 15. And we're just proving that these two sides are equal. I don't have 18 times 15 memorized, so I need to do some math off to the side. 5 times 8 is 40. 5 times 1 is 5. 4 more is 9. 1 times 8 is 8. 1 times 1 is 1. And I get 270. On the right side, so this, we could rewrite this, simplify it as 270. And then on the right side, I can do that one in my head. 10 times 27 is 270. So yes, these two sides are equal. And again, the reason this will help us solve a proportion is because if you can get one of these factors to be an X, or like a missing number in your proportion or in your factor puzzle, then you'll be able to solve that answer using the strategy of cross multiplication, where you multiply both sides and then you end up dividing one side to solve for your missing variable. So let's get to work. Number 1, I already know the answer because it is the same numbers that they used up here. They said 10/15 is equal to 18 over something, and this is the same fraction they used up here. 10/15 equals 18 over something. I know it's 27 because it's the same number that they used. It's the same example. So let's go to our next one. The way you would write this, it's 8 over p equals 14 over 21. And so what I'm going to use is this cross multiplication strategy, and it's going to be this. So this way is 8 times 21, and the other direction is going to be 14 times p, which I can just write as 14p. And they are equal to each other, because that is what cross multiplication shows us, is that both sides when you cross multiply are equal. So I would like to get the answer for p, which means I need p to be by itself. I need to isolate that variable, isolate that letter p. So I'm going to divide it by 14, because 14 divided by 14 is 1, and 1 times p would just be p all by itself, okay? And that will get me the answer, or on the left side of the equation, my answer would just be p all alone. And then on the right side, I can solve 8 times 21. I don't know 8 times 21 memorized, so I'm going to put it over here. And it's 168. So p equals 168. No, it's not. I did something wrong. What did I do? Oh, I'm not done. I'm like, well, that's not my answer. That doesn't make sense. I know what I did. It is 168, but we still have to divide by 14. So now that we have 168, now I need to divide by 14. Sorry, guys. I probably made that really confusing for you. I'll make it more clear in our next one. Now that we have 168, we still need to divide it by 14 to get our final answer. So 168 divided by 14. I'm going to go up here because I'm out of space. And 14 goes into 16 one time. 1 times 14 is 14. Subtract, I get 2. Bring down my 8. 14 goes into 28 2 times. 2 times 14 is 28, subtract and we get 0. There we go. That makes a lot more sense. So 168 divided by 14 is 12. That means P equals 12. And that should make sense because if we substitute our variable and we get P equals 12, that means this would say 8/12 equals 14/21. And yes, those are equivalent fractions. All right, number 3. I will try to make that less confusing and not make a mistake. Sorry, guys. So number 3, the right side of my equation going this way, 10 times 15. And the left side of my equation going the other way is going to be 25 times t. In other words, 25t. Now, I want the t to be by itself. But first, I'm not going to make that mistake again. I'm going to simplify my equation. So 10 times 15 is 150. Luckily, I can do that one in my head. Now I can isolate my variable, make the t all by itself. So I'm going to divide by 25 on the left side, which means I must also divide by 25 on the right side to keep it equal. 25 divided by 25 is 1, so the t is all alone. That was my goal. And then the right side, 150 divided by 25. Luckily for me, I can do this one in my head. I'm really good at dividing by 25 because 25 is like money. It's like quarters. If I'm counting by quarters, I could do 25, 50, 75, 100, and then 125, and then 150. And I would get 6. So 150 divided by 25 is 6. So for this answer, t is 6. If I check my work, does that make sense? 10/25 is equal to 6/15. Yes, it is. All right, number 4. S/40 equals 10/16. All right, so what we get to do is on this side of our equation, we have s times 16, which is the way we could write that is 16s, is equal to the other side is 10 times 40. Now I'm going to simplify this first. 10 times 4, I can do that in my head. 10 times 40, my mistake, is 400. And the right side is, I'm just going to write it again. This looks like a 5. It's not. I just am bad at writing S's. They look like my 5. 16s. Now, if I want to isolate that variable, make the S all alone, I'm going to divide this side by 16 to simplify that to 1, and then I'll just end up with S on that side. But if I divide by 16 on the right side, I must also do that on the left side. So now I am left with S over here. It looks like a 5 again. Oh, it's an S. 400 divided by 16. Now, I don't have that memorized, so I'm going to do that up here. 400 divided by 16. 16 times 2 gives me 32. Subtract and I get 8, and I'm left with 80 if I bring down that 0. I know I'm pretty good at 16s. I've memorized a lot of them. 16 times 2 is 32. 16 times 3 is 48. 16 times 4 is 64. 16 times 5 is 80. I just happen to have those memorized. So 5 times 16 is 48. 80. Oh my gosh. And we subtract and have nothing left. So 400 divided by 16 is 25. That means our answer is 25. S equals 25. That means 25/40 is equivalent to 10/16. All right, hopefully the strategy is making sense to you. If my couple of mistakes haven't messed you up too bad. We're going to do that same strategy down here. The difference is, instead of them giving us fractions, they wrote it in a ratio form. It says write the ratios in each proportion in fraction form, and then solve by using cross multiplication. So the key here is that if you have a ratio that's written like this, 10 is to 15 is equivalent to 18 is to x. If this is what they give you, then you have to turn this into a fraction. 10 is to 15, we write that as 10/15. And 18 is to x, we write that as 18 over x. So the trick is the first number in the ratio becomes your numerator. The second number in your ratio becomes your denominator. And now this is set up to solve like we already know how. Then we can just cross multiply like I've already taught you, like this, and you would end up with 10x on this side and 15 times 18 on the other side. Now this is a problem we already did. We started out the day with this problem. 15 times 18 is 270. And we know that if we want to divide by 10, we can get our answer. On both sides, x would be all alone, and then 270 divided by 10 is 27. So x equals 27 would be our final answer. But anyway, the whole point of that quick whiteboard problem was to show you that if you start out with a ratio with the colon, those two dots, the way you turn it into a proportion with fractions is that your first number becomes your numerator, your second number becomes your denominator. All right, so we're going to use that information to crunch a bunch of numbers. So the rest of this activity is just doing a bunch of math. It's, in my opinion, not a lot of thinking required. It's just a lot of numbers. Okay, so on this first one, we have 16 is to 20, so we're going to write it as 16/20 equals 12 to a. So 12 over a. So if I cross multiply 16 times a, which would be 16a, and on the other side, I have 20 times 12, and those are equal. So I'm going to simplify my left side by answering what is 20 times 12, and luckily I know how to do that in my head. It's just like saying what is 20 times 2, which is 24, but I put a 0 on it. And then that is equal to 16a. So now if I want to solve it, in order to get a isolated all by itself, I need to divide by 16. But if I do it to the right side, I need to copy it and do it to the left side as well. And I ended up with a on the right side, and on the left side, it's 240 divided by 16. I don't have that memorized, so I need to do a calculation. 240 divided by 16. 16 goes into 24. One time 16 is 16. 24 minus 16 is 8. And I bring down my 0. 16 goes into 80 5 times. I did that over here, I remember it. 5 times 16 is 80, subtract, and we get 0. So we end up with 240 divided by 16 is 15. So a, or 15 equals a, which is the same as a equals 15. So our final answer here, I kind of scribbled on our answer line, is a equals 15. Well, number 6. Let me put a little line in here so we can kind of keep ourselves organized a little bit. There, now we have some space to work that's semi-organized. Okay, so now we have the problem 18 over b equals 27 over 33. And I'm going to cross multiply. So on this side I have 18 times 33. And on the opposite side, I have 27b, 27 times b, which is just 27b. Now, I do not have 18 times 33 memorized, and I'm guessing you do not either. So I need to solve 18 times 33. I don't have a lot of space to write this, but I'm going to try 18 times 33. Sorry if this starts to get crowded. 3 times 8 is 24. 3 times 1 is 3, plus 2 more is 5. Put my placeholder 0. 3 times 8 is 24 again. 3 times 1 is 3, plus 2 more is 5. Add those together, and we get 594. So 18 times 33, we can simplify that to 594. And now that we're at 594, that's equal to 27b, but I want that b to be all alone. I want to isolate that variable. In order to do that, it's multiplied by 27 now. I need to do the inverse operation. I need to divide by 27 on both sides to make it equal. And that will leave me with my answer. But I don't have 594 divided by 27 memorized. So what I'm going to do is one more math problem off to the side. 594 divided by 27. Oh, I'm so running out of space. That's probably too small for you guys. I'm going to write it up here where I have a little more space. 594 divided by 27. Hopefully you can see that better. 27, if I double that, I get 54. So I'm going to put 2, and I get 54. Subtract, and I get 5. Bring down my 4. Hey, that's what I wanted again. 2 times 27 is 54. Sweet. So that helps me know 594 divided by 27 equals, I just got my answer, 22. So for my final answer, B equals 22. That means in this ratio, 18 is to 22, just as 27 is to 33. Those fractions are equal. Number 7, 6 is to 15, just as C is to 20. All right, so on my first step of cross multiplication, I'm going to do 6 times 20. On the other side, I'm going to do 15 times C, which I can write as 15C. I can do 6 times 20 in my head. 6 times 2 is 12, so I can put a 0 on the end because it's actually by 20. And my left side of my equation stays the same. It's still 15C. But now I would like to isolate my variable. I would like to divide by 15 so that my C stays all alone. And if I do it to the left side, I need to do the same thing to the right side to keep my equation balanced. So now I'm left with C equals whatever the answer is to 120 divided by 15. I don't know that answer, so I'm going to do that right now. 120 divided by 15. Oh no, 15 doesn't go into 1, it doesn't go into 12, so I just need to figure this one out. I don't know, I'm going to guess, would 7 work? No, because that would end in a 5. I think 15 times 8 would maybe work. So 8 times 5 is 40, carry my 4, 8 times 1 is 8, 4 more is 12. Oh, that's perfect, good. So basically 120 divided by 15 is 8. So this side of my equation simplifies to 8, and I end up with C equals 8. All right, next one, D is to 9. So D over 9 equals 4/6. All right, so the right side of my equation is D times 6. I can write that as 6D equals the left side of my equation, which is 4 times 9. Now I know 4 times 9 is 36. And on the right side, it's equal to 6D still. And this is one I can do in my head. This is saying 6 times something gives me 36. I know the answer must be 6. But if I want to show my work, I can say, hey, I want to isolate that D, so I'm going to divide it by 6. And I need to divide the other side by 6. And that will help me get my answer. 36 divided by 6 is 6. And on the right side, 6 divided by 6 is 1, so I end up with 1D, which is my answer. 6 equals D, so my final answer, D equals 6. Oy, that was a lot of work, kind of messy. Again, I don't think there's a lot of thinking involved in this strategy of cross multiplying. It's just a lot of numbers. Okay, we are almost done with this lesson. This is going to be a short one, you guys. Yay! Okay, number 9. This is basically the whole point of number 9. It's not the Puzzle Penguin one, that's next. Is having us look at 3 different strategies for one problem. Because there are so many ways to solve these problems, and the book just wants you guys to realize that you can do more than one thing to get the answer. You can choose which strategy you feel most comfortable with, or if you feel comfortable with all the strategies we've talked about, then do the one that makes sense for the problem, okay? So here's the story. Xander paid $7 for 5 avocados. How much would 9 avocados cost? Discuss how these solution strategies relate to each other. So basically, they already gave us the answer, but our job is to study what are the 3 different ways that they did it. So the first one is they used a rate table. They put dollars on the top and avocados on the bottom. So they used a horizontal rate table. And they started with $7 is 5 avocados. That came straight from the story. $7, 5 avocados. Then they did a 3-level rate table, or a factor puzzle with 3 layers in it. And they said that they needed to figure out 1 avocado's price before they could figure out 9. They had to find the unit rate. So they put a 1 here. How did they get from 5 to 1? They divided by 5. So they did the same thing right here. They do 7 divided by 5, which is 7/5. Now they can use that same idea. Now that they got it down to 1, now they can take that 1 and multiply it by 9 to figure out 9 avocados. So 1 times 9 gives them 9. And then on the top, 7/5 times 9. If you did the math for 7/5 times 9, you would get 63/5. Or 63/5. So the missing answer is it would cost 63/5 of $1. Now, they already did the math down here. If you did 63 divided by 5, you would get this. And you would get 12 3/5. And if you wanted to solve that as a decimal instead, you would get $12.60. I'm not going to do all that work because we're not doing the math on here. They're just having us check it out. But I will tell you guys that 12 3/5 and $12.60, it's the same thing. So this is a missing number. That's how you could solve it with a rate table. How could you solve it with a factor puzzle? Well, you can see they still set it up. They look similar. Dollars on the top, avocados on the bottom. They did $7 was 5 avocados. They wanted to figure out 9 avocados. So notice that in this factor puzzle, they just have a 2-layer one instead of a 3-layer one. And so what they did here is a little bit tricky. If 1 times 5 is 5, they slid across the 1. 1 times 9 gives us 9. The 9 goes on the top. And then they slid up the 5, and they go, wait, well, how do you get to 7 if you have a 5? 5 times nothing gives us 7. Well, actually, something does give us 7. It's a fraction. And it has to do with those inverse calculations we've been talking about. So if you actually did the math for 5 times 7/5, you would end up with 7, I promise. Look, 5 times 7/5, if you changed your 5 to a fraction, this would give you 35/5. And what is 35/5? Remember, the fraction bar is like a division bar. 35 divided by 5 equals 7. So it is true. It's just we're not used to seeing factors that are fractions. Personally, I don't love the strategy when you have a fraction on the side. I think it's complicated. But if you did end up taking your factor and sliding it across, you would do 9 times 7/5. And if you got that answer, it would give you 63/5, I promise. 9 times 7/5. If you turn your 9 into a fraction, you would get 9 times 7 is 63. 1 times 5 is 5. So that's how they came up with this answer. So again, if 5 avocados was $7, they showed you how you could use a factor puzzle to say 9 avocados is 63/5 of $1. Again, you would have to turn that into a decimal. Personally, I don't love this strategy. If you have to have fractions on the side of your factor puzzle, to me, that's not a good way to solve it. I would use a rate table, or in this case, what I would really do is cross multiplication. So here's my favorite strategy when you get a problem like this. They set it up for 7/5 because it's $7 for 5 avocados. So they kept their dollars on top, avocados on the bottom, equals C over 9. C would be for the cost. They don't know how much dollars it is, but 9 is on the bottom for the avocados. So if you can't see what they're doing, because I kind of scribbled on it, it looks like this. 7/5 equals C over 9, because it's $7 for 5 avocados, and we don't know how many dollars for 9 avocados. And then you can see they use cross multiplication. They did 7 times 9, which is right here. And then they did 5 times C, which is right here. The right side simplifies 9 times 7 to 63. The right side, C times 5, simplifies to 5C. And then if you divide both sides by 5, to get rid of that 5, to kind of isolate that variable, you end up with C on the left side and 63 divided by 5, or 63/5. Remember that fraction bar is just a division bar. So there's 3 different ways you can get the same answer. No matter how you do it, you get 12 and 3/5, which again, if you turn it into a decimal, would be 12 and or 12.60 or $12.60. So lots of ways to solve the same problem. Again, the reason that the book had you do this to study these 3 different ways is because there is more than one way to solve a problem. We've taught you a lot now, and you might be feeling overwhelmed with, oh my gosh, there's so many strategies. Am I supposed to use a rate table or a factor puzzle? Now we did cross multiplication. I don't know which one to use. That's because there's more than one way to solve a problem like this. And so you get to decide which strategy you feel most comfortable with and use it. Or if one strategy, like if you like factor puzzles the best, but you start doing it and you realize, there's a fraction on the side, I don't like that kind, then ditch that strategy and move to cross multiplication. It kind of just depends on what your numbers are sometimes for which strategy will be easiest. All right, now this last problem is Puzzle Penguin, and I think you guys will catch what he did pretty quickly. He says, "Dear math students, it took me 15 minutes to ride my bike 3 miles. I wanted to find out how long it would take me to ride 10 miles. My work can't be right because my answer is only 2 minutes. What did I do wrong? Thank you, Puzzle Penguin." Now, first of all, I want to say, actually, good job, Puzzle Penguin, for thinking about your math. Sometimes we do a calculation and we don't think if it's reasonable and we just move on and say it was correct without thinking. I love how he stopped to think about it. If it's 15 minutes to ride 3 miles, if you ride more miles, it should be more time. But it wasn't. His time went way down, so he knew he made a mistake. But can you see what he did? It's kind of hard to see on the camera. I'm going to write it again. He said, "It took me 15 minutes to ride my bike 3 miles. And then he wrote, so how long would it take me to ride 10 miles? Okay. And then he did his calculations. He did 10 times 3 is 30. 15 times t is 15t. Did his work, divide by 15, and he got 2. Now, his math here is good. But what Puzzle Penguin did wrong is this math doesn't matter because what he said up here, which is hard to read, what he said up here is bad. Can you guys tell what he did wrong? He did not set up his proportion with the same numbers in the spots where they're supposed to go. What he did is he said 15 minutes was 3 miles, and then he switched it. Then he said 10 miles, how many minutes? This is not okay. And this is one of the biggest mistakes that kids make when they are solving problems like this. And this is exactly why this Puzzle Penguin problem is in the book. It's because so many kids make this mistake. When you are solving, whether using the strategy of a rate table or a factor puzzle or cross multiplication, no matter how you set it up, guys, you have to have the same number on your numerator, not the same number, the same category, minutes, on the numerator, and the same category on the denominator. In this case, it would be miles. You cannot switch them. Like this one, the numerator was minutes, but then he switched it and the numerator was miles. That is not allowed. You will never get the right answer by doing that. What Puzzle Penguin should have done is he should have made a little ratio off to the side to remind himself how he wants to set it up. Minutes to miles is how he wants his proportion to look. So what he should have done is said, hey, I did 15 minutes and that took me 3 miles. And we're going to say that was equal to, instead of putting the 10 up here, he should have said, well, how many minutes or how long would be my time, okay, if I went 10 miles. This is how he should have set it up, is kept the miles on the bottom each time and kept the minutes on the top each time. Then he could use cross multiplication, and on the right he would get 10 times 15, and on the left 3 times t, and that would have simplified on the left to say 3t, and on the right 10 times 15 is 150. And so if you want to isolate that t, divide by 3, t is all alone, and then you get 150 divided by 3 which is 50. And that is the correct answer in this case. That's what he should have gotten, is t equals 50 minutes. Okay? And that would make more sense. If it took 15 minutes to ride 3 miles, it should take way more minutes to ride 10 miles. And it does. 50 minutes makes way more sense than 2 minutes. So that's what Puzzle Penguin should have done. All right, guys. Well, that wraps this lesson up. I guess the big takeaway is that cross multiplication, to me, is a pretty easy strategy. You just have to do lots of number crunching, lots of multiplication and division to get your answers. But to me, it's not very confusing. Some kids like it better than rate tables and factor puzzles because it's a pretty simple strategy. You just set up your two fractions and then you cross multiply. You have to multiply on one side, divide on both sides, and you'll be good to go. All right, good luck on your homework. See you for your next lesson.